Right, we've got a dumb 4-cylinder petrol engine from the 1920s. Starter motor to fix up or try and get it working better. Right, I'll take these 2 screws out the back. There's a grease nipple to take off the back there that's quite loose, look. Already undone. Right, we can take the back, whatever it is, off. Oh yeah, brush box holder.
What's the verdict, Doc?
Don't know. Smells alright, doesn't it?
Tastes good.
Right, I'm just going to take these 4 screws out here, this end, so we can pull the armature out and see what's going on. Right, we'll just see if it pulls apart. Oh, it does. Oh, look at that. That'll come out nice, isn't it? This is cleaned up. Someone's cleaned up the field coil inside, look. Looks like rubber coated, like it's got like a thick shellac on it. I don't think we'll be able to clean it up, will we?
No.
That's quite thick. I got told off about that. Bloke in Germany broke down and his dynamo was covered in red paint. Right, the spring, it just pings off, well it doesn't ping off, it threads into these grooves around the outside, so the spring comes off. It looks like there's a split pin, and then this should hopefully turn round. But the issue we've got is this end float in there. Oh, that feels like there's a spring there, isn't there? Look at that, look, what's causing that?
This is a leaf spring or something.
Oh, so this spring's collapsed, is it?
Maybe, yeah.
Oh, I can slide it this way, look. I can slide it that way, look.
Oh,
yeah. Yeah, so something's gone wrong inside, isn't it? So it wants to be out here, doesn't it?
It does, yeah.
Does it? Or there's no play in that though then?
Well, that's because that's missing.
Oh yeah, yes it would be there, wouldn't it? And then that would come to there.
Yeah.
That would, so there's something we've got to...
There was ½ an inch, wasn't there, of play.
Yeah. Oh, that's all like a springy plate material, look.
Mm-hmm.
So it is a spring, isn't it?
So it's worn on that brass piece.
Yeah, yeah, it's worn that. Oh, we'll have to have a look at that then, won't we?
Yeah.
Right, I'll best turn the camera on. Right, so we've found a spring here that pushes the bracket back, and it was sat a bit funny at the bottom as well, and it's worked its way out, freed off a bit. So
it's seized, wasn't it?
Yeah. So we don't know whether to take this off here. We've got the split pin out and took the spring off, obviously, and then we don't have to take it off and make a tool. So this to pad this out a bit more to make, but it's not too bad now, is it?
It's a lot better.
Yeah, so we'll probably see how we get on. So this is the car it's off. 1920s, Ruston's car. Right, I don't know if you can see that, it's a bit hard because the brushes are offset. See that one brush there, one brush there, and one brush there. And so there's 2 speeds. So we've got to try and work out how that works. Right, so we've got the armature. We're going to try and test the commutator. So one way to do it is you've got to check, see if it's down to earth. And that's a bit awkward like this. I'm going to try. But I don't know how this one's connected up, but you'd measure. Sorry, let's do it a bit there. Well, you'd measure. See if you've got a connection between each segment, but you could do it like this and work your way around. I'm not an expert at this, I just know you've got to make sure each one's connected. But I don't know how the wiring this goes, but with the brushes being offset it's a bit strange. They're just about the right angle. No, it's still 0.3, so anyway, I'll dig around all of these and check them out. So there's that little spring thing in there, look. It keeps the brackets. I've just sprayed it with WD-40 and that's springing back nice and lovely now, isn't it? So here we have the field coil. We've got 4 terminals, 1, 2, 3 and 4. So we're going to try and find out what they are. What can we read on them? That says positive. This one says A minus. This says P. And this one here says S. So whatever that means. And we'll have to try and have a look inside, see where they go to, and measure the field coils. Sorry about the lighting. So this S terminal, I've looked underneath, comes up here and goes onto this brush here. and we'll have a look around the rest of it. Oh, I said P, I meant B minus. So this terminal there, this is S terminal, this terminal here goes, oh god, oh my lord, goes into the field coil here, and then that goes into that wire there to the next field coil over the other side. And I presume it makes a circuit all the way around. I'll have a look now. Jipers. So this connection, the next one round, is A minus, and this is connected to the other end of the field coil. So that's the field coil circuit. A and B is a field coil circuit, and positive and negative we don't know yet because they've both got a minus on, which makes sense, doesn't it? Help you out. So that's that. So this one I presume goes to the brushes, which come up here I would think. And yes, you can feel it coming up, whether it goes anywhere else. So this one here, the plus is the armature, and the S is the armature. But we've got all these other brushes here, and there's also this weird thing. Let me show you this. On one of the brushes there's an adjuster, so you can actually adjust the angle of the brush. So we're going to presume, well, we're not going to touch it, you see. No way we're going to touch that. Or we could mark it, couldn't you? But anyway, it's set in one place, and it's got four pinholes, punches, so it's lined up with them. So it does move, you know where to put it back. Strange one. So we've got 4 connections. So I'm thinking we've got a plus connection there. We've got a A minus and a B minus, and S there. So I'm thinking that this is the first speed A minus, and this is the second speed. So you put in positive, and it goes to 1, and then it switches to the next one to go faster, or turn them both on. I don't know. And S is to start the alternator to the armature to turn the whole thing on. We'll just do some resistance checks, see if we can find out which is which. So this is across the field coil, and we've got 0.3, oh sorry, 0.3, look at that, what an idiot, 0.3 of an ohm, which I suppose is reasonable, isn't it? But when I touch this on the other terminals, nothing. So it looks like the field coil is completely independent of the armature circuitry. So somehow, hey, what's going on there? Oh, I'm telling you wrong. Well, what I've got is either this, the field coil comes in these two here, the power in and out. But what it also does, it goes to the armature through the middle, so it goes through 2 coils to the middle of the armature, and then there's another 2 coils to the other side of the output here. So if I do this and that, this will be in the middle. Oh, I can't see it again. I'm doing it again. Look, I'm getting too old for this camera work. So if I do that, we'll get 2.2 ohms, and then I do this on the other side. The field coil will get about the same. Should be the same. Roughly. Anyway, so it goes into one, goes through 2 coils, goes up to, well, it goes to the other side of the field coil as well, but it also goes up to the armature. So this is something to do with the speed control. So when it first engages, it doesn't go full speed until it's fully engaged. That's what we're thinking anyway. So I've done some resistance checks, readings. It looks like the speed is controlled by having A or B earthed, just one at a time, so you've got 2 coils, or these 2 coils going to earth, so you're going to get half speed, or whatever it is, and then probably when it gets on full speed you earth both of these, and then it goes on to full speed. So it looks like when you turn, well, I'm just guessing now, when you turn the ignition on, this goes positive, so, and these disconnected, so you've got power going in, but you've got nothing going out. And then when you want to run the starter motor, this is your switch on your dashboard, on on your ignition switch, whatever it was in the 1920s. Bloody hell, yeah, 100 years ago. Anyway, so yeah, this must be the switch to activate the armature that must operate at the same time as one of these. So perhaps this one and this one connects, and then when it gets going full speed, this one can half speed or whatever it is, this one connects as well to Earth. It goes into full speed. How the hell does it know to do that? It must have been a timing device, perhaps. Oh, they don't have timing devices 100 years ago, so I'm just confused. Yeah, I don't think they had negative earth back in the old days, so these earths would have to go through a separate wire back to the battery, or through the relay, or through relays. Did they have relays 100 years ago? Through some sort of switch. Yeah, I don't know when they got earthed bodies. I'll have to Google it. So we've got a bolt missing, a screw missing, and I think it's in Whitworth. So we're going to measure across the thread for a start and get what it is. 0.18. Is that zeroed? 0.18 of an inch. Looking at this Whitworth thread profile chart that I've stole off the internet, it looks like that's us, 1.87. That's got to be the closest, isn't it? So 3/16 thread bolt size width. So now we've got to find the thread width. I put this one here, which is unified, which is not the right one. I've got this one here, metric, millimeters, and this side is Whitworth. So this is the side we're going to be looking. I think we'll start with this side here. Looks the finest. So what we do, we get each one of these and we put it up against the threads until you get one that matches. No, I've gone the wrong way. It needs to be a bit finer. Well, it's either 30 or 32 threads per inch. Oh. There you go, look, 30 threads per inch, fits in quite nicely, doesn't move, and 32 also fits in nicely, so it's either that, one of them. And on this chart it does say 3/16 32 threads per inch. Fine, pretty standard fine. So I think we're going for 32. Underneath, inside the fill coil, you can see how much cleaner it is. I cleaned it out with a Lexol, which is some solvent I got from a factory I worked in that did military starter motors. Just using a bit of IPA to clean up the brush faces, because just in case it's got any contamination on them. Bit of muck come off, but I mean, you are going to get a bit of muck off the brush, aren't you? Brass brush. Oh, you know what I mean, carbon. All greased up. Put a bit of grease on the inside as well, because you can see there is a metal against brass, pressed steel against brass, and that's what pushes it back. The spring, and I think it's worn away quite a bit. There is a little bit of distance before it touches, a few mil, 2 mil, so that is not perfect, but we're going with it. So now we can assemble this into the field coil body. See, this is the bit I was going on about. Let's try and get in focus. So any grease that comes down here goes onto this plate and it gets flung out by a centrifugal force away from the commutator, not contaminating it. Sorry about the noise. But when you are putting a motor together, you can get a little hook and just pull this little spring out, unspring it, but I'm not going to do that because this is too old to be unspringing things. The wires looks like it's been caught round there, you know. Don't look very good, but anyway, I'll have a look at that. But you can on new ones, you can pull these out so far and pull them around to the side, hook them over, then push the brushes out so they're out of the way so the armature can slide in. But this, when I do this, I'm going to have to push the armature in and then just pull one brush out at a time until it goes over the armature, which is a pain in the arse on your own. Well, I managed to get the wire untangled. It was all wrapped around this back spring, which is not going to help, is it? So that's a bit of an upgrade. I was a bit worried about damaging the copper wire because it's really old. So as I push the armature in, I'm going to, oh dear, it's already gone into the bearing at the back. I'm going to use a white paintbrush to push it back, or perhaps not because it's not strong enough. No, I was going to use a paintbrush. But anyway, get the armature up to the brushes, just keep working each one back at a time until you get over the obstacle. So I'm going to have to do this off camera because it's going to take a while. Well, I got it together, but all the grease popped out the back, look, all over my hand. Yeah, I found the best way was just to put your fingers in, turn the rotor around, turn the armature around a little bit at a time, and just put your finger in and just push each brush out of the way at a time, and you'll feel it just move slightly, and then it goes on all together. So it's turning, a bit rough, but oh, the brackets come off again. There you go. Oh, yeah. I'm going to put some screws in. There you go. Look, that sounds better, doesn't it? I'm going to go and wash my hands and have a wee. Can you see that there? Look. Let me get my screwdriver. Can you see that slot there? It comes down to here. This is where the spring sits in this slot. It's got a nut here that tightens down onto this plate. So them clever sods back in the 1920s put a nut on here you could loosen off, so you could undo this brush at the spring to release this round. You could release it round so you get the armature in easier. And I've only just spotted that. How clever! Let's get some numbers. ZB10753 V12G. That's going to the eye clinic, isn't it? That's all I can find on it. I'm doing a resistance check now. I've got to put the lid on. Just going to make sure everything's working alright. Not shorting out. So we should have a nice load there, 0.5, 0.4, 0.3. Just make sure I'm not connected down to earth. This should be across the whole field coil. This should be to the field coil. This should be to the field coil. This should also be to the field coil, and this one as well. So yeah, nothing's down to earth. I've managed to get a screw from work, same size as the other one, 32. Oh, I'll put it away now. But anyway, I've measured it and it's 32 teeth, and it's 1.8 mil that way. 4 point. Oh, I can't remember. Anyway, but it's the same size as these, but it's too long, so I've got to chop it down. And I've got some slip pins for the end. So I'll try and find the right one for that. And I've got a split pin that's about the right length as well, so I've tried to line it up because the holes aren't quite lined up. Oh, it's twisted round now, so it's not quite lined up there. Look, I'll have to bend that around into there. Can you see that? Bend that around into there, look. Well, that's a split pin in, and this moves quite easily really. I thought it was a bit tight before, but in the end float, it has got some end float, look. Oh gosh. Oh, I can't do it now. I'm not. Oh dear. Oh, it did move a minute ago. Oh no, come the other way, sorry. There you go, look, there's the end float. It has got some end float. Oh. But does it go back on its own? Virtually. I think it would do if it was spinning. It does spin quite free, so hopefully that's the problem. And so the next job is to put this spring on the end. And that pulls, that hooks, that goes in the end there, look. And it hooks on to these things here. It pulls this gear back, so it's like an inertia starter motor, like the mini starter motors. This is a mini starter motor, inertia starter motor, and this works on the same principle. So when it starts spinning round, well, that's quite stiff. The inertial force puts this into the flywheel, and then it turns the car over. So we're sort of looking for that sort of same comeback on the other start motor. So there's a little nip, there's a tooth missing there, so I presume that's where that bit sits. Otherwise it might have just fallen off. So I'm going to spray a bit of WD-40 on the, I'm going to actually, better be careful when I roll my cigarettes on here. Bit of light oil, both ends. You don't want heavy oil because the clutch dust can contaminate it and build up a sludge, but that's good enough for me. So I've got the spring on, fitted alright, so you can see now the gear returns very well. It was a bit sloppy before, so perhaps it was in the wrong, perhaps it didn't have enough of the spring on, perhaps it just, so it fitted in that little gap there perfectly. It didn't fit in where there wasn't a gap, so this has got to be right, but I'm happy with that. So what I'm thinking is that big spring inside here that makes that shaft move down. Oh my god, the camera nearly went. It's a similar thing to what this is here. This is a spring-loaded thing, so when this gets here, this gives it a bit of. Obviously, it won't come out that way, but and I'm not strong enough to do it. But I think that's the same thing as what that is in there. So it's working. And what I mean is that spring there is this, when this comes into the flywheel, if it encounters a problem, if it catches on the flywheel and it gets withheld, what it'll do is it'll pull out the shaft a little bit and turn a bit more until it engages into the flywheel, then it'll just carry on engaging. Just to stop things wearing out a bit, I think. Just going through some pictures, and it looks like this. I mean, this starter motor has got no fixing holes on it at all. It looks like it's got some bands going around the outside that position it in this direction. So if you loosen them bands off, you can move it this way or that way. This picture is a wire. I'm going to have a cigarette now because it's tea. Oh yeah, there is, look, there's clamps. I thought the paint was worn out on the body, so you could actually move the whole thing this way further. So I would try that first. These are in good condition. These gears are there, so that's not been a problem. But I would just pull. Well, I don't know what's going on here. That's obviously the top because the oil goes to the top. So this is some sort of mechanism. This might be the mechanism that switches the starter motor on full speed. I don't know. And here we have one from the underneath of the car, I should presume. So yeah, there you can see that cutout that I was on about. That is right, I was right. Oh, good. Bit of paint on the old shaft there, but it doesn't matter because that doesn't go inside. The whole thing comes out outside. As this moves in, catches on the flywheel, any problems, it'll pull the whole shaft out on the spring. I wish I could paint this. And this is outside the Ruston's factory in Lincoln, and I work across the road in a steel forge, but I have worked in this factory when I was 16. I was a YTS at Marconi, and Ruston's Marconi was the same company sort of thing, and we did apprenticeships in there, learning how to use a lathe, learning how to the chuck key flying out all over the place, smashing into people. It was a regular occurrence. as you can imagine. Right, here's some of the test sheets, the wiring diagrams, and I can't really understand this one properly, but I can understand some of the other ones. So there's the first, before the switch is engaged, so I imagine this is when the start motor is turned off. Before switch engaged, yeah, so what that line means above there, I don't know. I mean, all the terminals I can get is this one, A minus, A, B, S and plus. So, well, sorry, A, S, B, and there you go, they are. So, God knows, we'll try the next one. So this is the second, or first switch position. It says second stage, so first switch position. So this is where you turn the start motor on. I presume power to one pair of field coils. So B coil gets. So B coil gets first. Does it say second there? Yeah, it says second. So that means that dotted line. Third stage. It says, oh, what's it say? As cam releases, so it must be automatic. Must be something on the car. So as cam releases, oh god, I still don't understand it. Both power to both parts of field coil. So, oh, so that means that dotted line means connected up. So, based on rebuilt contacts. I don't understand that bit of it. It's time to test it, and I've got a really flat battery because I don't want the starter motor flying all over the front room, because I'm in the front room now. And so I've got the positive connected up, which is one side of the armature, and then A minus, which is just 2 field coils rather than all 4 field coils. And so I'm just going to put the positive on and just hold my hand there, see if it spins around slowly. Oh yeah. So that bit's okay. Okay, so that was a slow speed, and you can notice this come out about that far, so it's starting to engage into the flywheel, but not on full power, so it doesn't get ripped apart. So now I've connected both the field coils, so the full field coil is connected up. So we'll just put that on there. Oh dear. And this should spin over a little bit faster. Oh. I'm going to get a tachometer on it, aren't I? Okay, we'll connect up the armature. There's another. Connect both sides of the armature up to positive. Okay, so now this should be full speed. It's only pushed in there. I hope it don't fall out, but I'll just to see if it works on full speed. Right then, here we go. Oh God, wish me luck. No, that's not good. Don't like that at all, does it? Let's try it again without that on. This must go to earth then. I reckon it goes to earth. Something's wrong there. Yeah, okay. Oh, right then, back to the drawing board. So now I'm going to try both the field coil circuits connected and the S terminal on positive, and disconnect the positive terminal. See if that makes it spin any faster. Right, here we go. Best hold on again. Oh no, that's not doing nothing. Okay, that's not working. So we're best come back and look at the wiring diagram. So it looks like on start position, none of the zeros, none of the A and B field coil connections are earthed. This is before the switch is engaged. Before switch is engaged, and the switch looks like it is connected to the positive. So we'll go to second position. So the second position is that the switch is still connected, but the earth is connected to the B. Oh, B plus. Oh, I thought it was on the A. We'll try that then. Okay, we'll try that then, and let's see what the third position. Third position is. This is, oh bloody cats! Don't, Shelley. So that looks like both field coils earths are connected, and the switch is disconnected, but the positive is still connected on there. Which I think we've tried that already, haven't we? And the fourth position, I can't see any difference there, it seems to be the same. So we'll just go for the instructions. Fast speed position, which I think we've already tried this already. So I can see if we can reach around the camera with that. So both the field cores connected and just this one's connected there. That battery's getting worn out, isn't it? I think we'll put it on charge. Right, I've charged the battery up a bit for an hour or two. So I'm just going to try it on what is full blast, and I'm about stuck for what to do, so this will probably be the end of the video after this test. Thanks for watching. Hope it won't blow up. Oh shit, it did blow up. Oh shit, it's not working. Yeah, what I meant to do was put this positive on this one down here, so I don't think that other one works. The cat's in the bloody way again. Come on, Shelley, you get electrocuted. Oh shit, that looks better, doesn't it? Here we go, let's try this. Yeah, I think that's alright, Jim. Can you see the rotor spinning round? Well, I think that's working alright.